This video is about stoichiometry, which is quite an intimidating, clever sounding word, but it's actually a really simple concept. And this is to do with moles again. So if we just go back to what we already know about moles, a mole is defined as this many particles. So it's just a measure of the number of particles there are in something. And we also know that it's related to the mass using this relationship. The question remains then, why do we need to bother knowing how many particles there are, knowing how many moles there are? Why don't we just talk about the mass of something? And stoichiometry is where moles are really useful. Stoichiometry just means ratio in a chemical reaction equation. Stoichiometry. So it's the ratio of the reactants and the products I'd recommend at this point, if you haven't already, that you are familiar with symbol equations and how we balance them and why we do. So I've made videos about this. So the fact that we need to balance symbol equations that show chemical reactions. And then I also made a video about how we balance them, about the method of putting numbers in front. And I explained it by saying the reason we need to do this is because 2 molecules of hydrogen will always react with 1 molecule of oxygen to make 2 molecules of water. That's the ratio that they will always react in. That's stoichiometry. But another way of saying that is 2 moles of hydrogen will react with 1 mole of oxygen to make 2 moles of water. So these big numbers that we put in front of the reactants and products when we balance symbol equations tell us the number of moles, or tell us the ratio of moles that react with each other. And that's what stoichiometry is. So we can use it to answer questions, to work out the ratios reacting. So first of all, let's go with this example, the reaction of magnesium with hydrochloric acid to make magnesium chloride and hydrogen gas. We're asked, if we've got 8 moles of magnesium, how many moles of hydrochloric acid would react with them? Okay, well here's our ratio. There's no number here, so that means 1. If we've got 1 mole of magnesium, it would react with 2 moles of hydrochloric acid. So to get from the moles of magnesium to the moles of hydrochloric acid, we've got to times it by 2. It's a 1-to-2 ratio. So, therefore, because it's 1-to-2, if we had 8 moles of magnesium, we've got to times the 8 by 2, and it would react with 16 moles of hydrochloric acid. Next question, how many moles of magnesium chloride would be made by 8 moles of magnesium? So now we're looking at the relationship between magnesium and magnesium chloride. And both of them don't have a number, so that means 1 in both cases. So this time the ratio is 1-to-1. 1 mole of magnesium makes 1 mole of magnesium chloride. So therefore 8 moles of magnesium would just make 8 moles of magnesium chloride. Okay, just to make it clear, I'll just go through one more example so you can see a different example. This time it's the combustion of hydrogen gas. So it's reacting with oxygen to make water. So we're asked, how many moles of oxygen are required for the combustion of 0.7 moles of hydrogen? So we're looking at the relationship between hydrogen and oxygen. We know hydrogen, we're trying to work out oxygen, so let's look at what happens. Remember, this is a 1 in front here. So we've got a 2-to-1 ratio, and we've got to divide by 2 the number of moles of hydrogen to tell us the number of moles of oxygen, because 2 divided by 2 is 1. So therefore, what we've got to do for this, if there's 0.7 moles of hydrogen, we've got to do 0.7 divided by 2. So that's 0.35 moles of oxygen that's required. Last bit, how many moles of water would be made by 0.7 moles of hydrogen? So now we're looking at the relationship between hydrogen and water. And 2 moles of hydrogen makes 2 moles of water. So this is a 2 to 2 relationship, or to make that simpler, because it's a ratio, it's just the same as a 1 to 1. 2 moles of hydrogen makes 2 moles of water. That means 1 mole of hydrogen makes 1 mole of water. And 0.7 moles of hydrogen would make 0.7 moles of water. So I'm going to write the answer very simply. It's just 0.7 moles of water. So there you go. The reason why we need to know about moles is because the ratios in chemical equations are telling us the number of moles.